Hello, everyone, and welcome to Microscopy. So this would be the virtual I2K version of the workshop we have already given in Milan at I2K 2024. And let's look at what is it about with segment analytic for microscopy and what are we talking about today. So this model comes from Meta AI, formerly from the FAIR team, which is called Segment Anything, which is a model created for promoting interactive segmentation in a model fashion. And thanks to Meta for open sourcing pretty much their entire code framework and the trained checkpoints. And what is the idea of Segment Anything? In a nutshell, if you see on the left side, you will see the particular points hovering around the frame. These are called input point prompts, which is basically to interact with an object of interest and try to segment the object using what they call user prompts. And what essentially it does is it does a positive interaction to select what object it wants to segment, and a negative interaction, so say the negative prompt on the snail, to segment it out from the entire frog's objective. And extending this prompt-based objective, what automatic segmentation, automatic mask generation essentially does, thanks to Segment Anything again, is that it places a grid of points around the entire image and then segments the objects of foregrounds of interest per prompt and does some non-maxima suppression and downstream post-processing to select the most valid objects of interest. Now, what is Segment Anything? We saw everything pretty much here. And why is the hype? Is someone's mic on? I'm sorry. Yeah, thank you. What is Segment Anything all about now, and why the hype of something what we just saw? So Segment Anything initially proposes and promotes, or tries to promote interactive segmentation, in which you can segment almost any kind of an object of interest by providing weak prompts or annotations, for example. And what does this mean? These prompts could be either points, boxes, or masks. And this can also be extended to text prompts. So basically, if you write, segment me a cat out of these two cats with long ears, for example, it should in principle be doing this as well. But this is currently not supported from the open source version of Segment Anything. And you can also interactively try to add more prompts, a more positive one or a negative one, wherein, for example, a positive prompt would go where the model did not predict an object, or a negative one would go where the model made a mistake, for example. And this should improve the segmentations for your use case. It is quite versatile, I would say, because the community already has seen a lot of advancements on Segment Anything for different domains. And this can easily be integrated within different pipelines that provides weak labels or input prompts from the user, or potentially from other object detection methods, or potentially nucleus seeds or spots for your foreground objects. And the cherry on top of all of this is the model is open source, which we are a big fan of. Now, how does this generate such a versatile segmentation objective? So it trains its own model in an iterative fashion on a large data set with a huge diversity in the source images and the grain of objects it wants to segment. So it could be segmenting something as small as a fruit or as large as a building, for example. And the best part we like about this is that it trains in an iterative fashion, which simulates a user's correction with a positive and a negative interaction. What does this mean? You put a positive point to get a better segmentation objective of your foregrounds, and a negative to eliminate the objects which were clustered together, for example, or segmented as a multiple objective. And where do we come in here? So our interest for this model was to check if Segment Anything can be translated, speaking for its success for the microscopy domain. And the first thing what we started to try is interactive cell segmentation and phase contrast microscopy, wherein you see for sparsely distributed cells, it does a good job. However, for clusters and cells which are touching each other, it needs often a lot of interactions to get something what you would desire. And the automatic segmentation, which was the grid of point-based method, just does not work as one would desire for microscopy out of the box, primarily because the model never has seen these images, and this is a bit more challenging task for the model, natively speaking. And the question we started to ask ourselves is, can we improve it for microscopy? And the answer is, you guessed it, yes. So we saw that once we fine-tune this model, segment anything for the microscopy domain, we saw that our light microscopy generalist model, what you see as an application in front, shows that interactive cell segmentation does improve. And you see that for sparse objects and densely connected objects, it does an okay job. And the automatic segmentation method, with some minor things and issues here and there, does a pretty impressive job to at least start with. And if someone wants to rectify something, they can start and go back to interactive segmentation to get a bit more rectifications as one would desire. So segment anything for microscopy is our effort. How do we improve this? Boop, 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 boop. The important stuff should be shown. How do we improve this? So we extend the model's architecture for better automatic segmentation, which is instead of placing a grid of points, we do a unit style training. So we use the vision transformer as image encoder, and we stack a convolutional decoder to learn instant segmentation objectives for us. And this is how we extend the model architecture to do better at automatic segmentation, what we saw in the previous example. We re-implement and extend the SAMS training, which wasn't open source in the beginning. And then we extend our application to volumetric segmentation and tracking objectives. And finally, we try to train a vision foundation model on a large and diverse microscopy segmentation dataset for two distinct objectives. One is for cell and nucleus segmentation in light microscopy domain, and another is mitochondria and nucleus segmentation in electron microscopy domain. And these can be easily extendable to like similar-ish looking organelles and cellular structures, but we come to that in a second. And our work has been out for a bit over a year now in bioRxiv, and we recently got accepted in Nature Methods as well. So what are the improvements? Can probably leave it here, I hope. Oh, yeah, yep. So we see that there are improvements in interactive segmentation when one compares from the default segment anything model compared to our fine-tuning model. And we see this for the light microscopy domain quite effectively. When you put one particular point prompt for segmentation, it does segment it in sparse and densely collected cells and structures. And if you want to look at the details of the experiments, you can check out our preprint. We will release, hopefully in the coming few months, the final version of the publication, which has all the updated experiments, the latest version of our models with all the downstream tasks, and a bit more explanation about the improved automatic segmentation. And feel free to ask us questions if you have any about the methods what were shown here. So what does this translate for us in the context of tooling and software? So we translated all our framework into Microsam, which is our Napari plugin. And currently, our Napari plugin enables users to do interactive and automatic segmentation for 2D images, 3D images. It also enables you to track on 2D images over time. And you can also fine-tune on your own custom data. We currently recommend to do this using script or notebook as it gives you much more control. But if you want to just get started with things and play with a few things, you can look at the fine-tuning UI as well. there was a fix made recently, I think yesterday or the day before, there was a minor issue, my bad, but it's fixed as well now. And the core functionalities of the backend Python library is also supporting some of these important features for the default and the generalist models for light and electron microscopy. And it also supports multi-dimensional segmentation and tracking in interactive and automatic segmentation modes. And we also support tiling window-based prediction for very large images, for example, which is the case for histopathology or potentially for large volumetric electron microscopy datasets. So the workshop would be divided in a few parts. So we go step by step with me trying out 2D and 3D segmentation. This part would be literally interactive, wherein I try to do things and you try to ask me questions. And we work on things together to see if everything is clear to get started with the next step. That is, we have provided a few tasks over here, and we would be happy if you choose one or potentially all if we have time to see if we can make things work for us. So the first one would be high throughput annotation of cells in 2D and 3D segmentation in light microscopy, 3D segmentation in electron microscopy, fine-tuning a SAM model on your own data. If you want, we can also go through this together. And if you want some advanced scripting tips or discussions, I would be happy to discuss with them. And this is the link which Luca has already sent. If you don't have it, please check the chat. You will see the repository link. If not, the first top level directory in the Microsoft GitHub repo is workshops, and you will have everything open for you. Okay, now let's get started with the interactive part. So I think I need to double check. Yes. So let me check the chat to see. To hide. Okay. Are there any questions? That's what I was trying to check. Yes, I see everyone now. If you have any questions, you can drop the messages or questions in the chat, and Luca would be happy to answer them. If I get an eye on the questions, I will try to help Luca as well. But let's already get started with the Napari plugin. Do you see my terminal open in front on the screen?
So, Anwai, for your information, all the participants are muted up until we select one to speak. So they will not answer you for now.
Yeah, I was looking for thumbs up, but that would be good to know. Thank you, Luca. Just give me a thumbs up when you have any issues and we can see. Okay. So once the installation has been done, you will have to open Napari, but by just typing Napari in the terminal. This will open the GUI interface for you. Now, the first thing we will try is opening one of our sample images. So let's try with the live cell example image. And if I'm too fast, just let me know. I will slow down. Okay. Then we go to plugins, wherein once you have done the installation, segment anything for microscopy should directly pop up over here. Once you have this, you can go to annotated 2D, and this opens the widget for you over here. Now, I will pull this here so that everyone can see things. Yes. Now we have the image open. Now, there are a few things which I won't go into the detail, but I will walk you through a normal workflow. So once the image is open, we have the widget on the right and the layers open on the left. Now we go ahead and select a model of our choice. For simplicity, let's start with the default segment anything model as a natural choice for segmenting objects for us. So we go to VITB, and then the next thing what we have to do is compute the image embeddings. What this basically means is that we run the vision transformer once with passing the image from there, and the image embeddings coming out of the vision transformer, we store them in your system. Because vision transformer is the most expensive to run, so often it takes a few seconds, if not minutes, to run this, depending on the scale of your images. And potentially this should work. So we pressed on compute embeddings. Let's see. Okay, the compute embeddings did run. There's a progress bar over here, which I forgot to hint towards. But whenever you see me pressing a console, you will see a progress bar over here running. For simplicity, let's open the activity console so that we can see things. Now, the first thing we can try is the automatic segmentation. So we run this with the default parameters provided by segment anything. And the details are not important what these parameters refer to, but if you are curious, I would be happy to answer. Let's press on automatic segmentation. And this takes a few minutes. As we see in front, the activity bar tells us. And usually what it's now doing is, as we discussed, placing a grid of points over everything, then trying to segment, or at least attempting to segment these cells or objects, what it can infer for, and then giving us an output by making some post-processings happen. Okay, meanwhile this runs, will it work for NIR or hyperspectral images? Could you mention what NIR is? I'm not sure. Maybe you can write it in the chat. That's also totally fine. Near infrared. How many channels does this have? So without even hearing the question, just to give you a highlight, segment anything by default runs for essentially images for one channel or three channel only. Why do I say it works for one channel? Because internally, Microsam has a heuristic in which we translate one channel images to three by stacking them on each other. Or if we have a three-channel objective, we use it as an RGB objective out of the box. And then we run the segmentation operation on this because this is kind of hard-coded in the model. If we change this, in principle, this should be fine. But one would need to fine tune again because the model weights would stop working because we changed a parameter value. So in principle, this should work, but it depends a bit on the, let's just say, use case value. So I would say I'm more inclined to say if you have a one channel or three channel objective, this should be a good starting point to see with the segment anything model. And then you can take next steps to pretty much fine tune models, get better instance segmentation, which we will see in a second, and some other things as well. Okay, so we see some segmentations. Let's view the segmentations. So it doesn't do a good job for this. For sparse cells, it does a pretty okay job, I would say. But for the others, it falls back to the rather easier task, which is just segmenting these boundaries, for example. And for now, let's switch this off and try interactive segmentation. So for now, let's say this is something as an automatic segmentation objective, which I don't like for microscopy images. Now, worry not, we can try interactive segmentation. So let's go ahead with the box prompt. So you have to select the prompts layer and go to add rectangles. Once you press that, you would have to place a box prompt like this. And you can select segment object over here. And there we go. It looks like a pretty okay segmentation, considering this model never saw microscopy images. Okay, let's go ahead and commit the objects in the current layer over here. Okay, now let's try to segment something quite dense. So let's say this cute smell cell over here. We go ahead, we put a box prompt over here, and then segment this. We see that it does an okayish job, but there's still some leakage on the outside for or over segmentation happening. So we go to point prompts now, and then click in this region switch to a negative prompt, and then rerun the segmentation. And then we see that there are distortions, but we can go ahead and add more point prompts to clarify the objective. For simplicity, let's stick to this for now and say that we are comfortable with this segmentation. Let's go ahead with something else. So for now, let's start with a box prompt. So I see an interestingly long cell over here. Let's see what segment anything does using point prompts only. So we put a prompt over here and voila, it does not see anything. It's rather due to the low availability of contrast, cannot pretty much see anything. But we can put negative prompts on the background and try to improve this. So I see there's a part over here which can be improved. There's a part over here which can be removed, a few more, maybe one here. And it does not do a great job. But for now, let's say this is something we are again comfortable with. Let's go ahead and commit this. Now, let's say in principle, this is a segmentation which I made by mistake. I also committed this, and this is not what I want at all. So you can go to committed objects layer, click on eraser, and then erase pretty much everything. Boop, boop, boop. Yes. Now this should be gone. Now let's try something. So we have support for polygon lasso tool, which means that basically if you put a polygon as a freehand around this object, this in principle should work for segmentation. So what this tool essentially does is translate these points provided into a box and a label, and then uses this for segmentation using segment anything. Let's try segmenting with this, and looks like it does a bit better job compared to the other prompt objectives we used. Now, let's say we are now fine with it and go ahead and commit this. And there we go. We have things segmented for us as we desire. Any questions on this part so far? You can also raise your hand and I can, Luca can provide you access to speak if someone has any questions. Okay, I don't see any questions or raise of hands, but I will go ahead then. So let's say we are fine with this and we have explored segment anything for interactive segmentation and automatic segmentation. Now let's see how our fine-tuned model works for this particular task. So we can stick to this, and let's say we are confident that none of the segmentation is helpful for me, for example, then we can just directly switch to the VITB LM model and then compute embeddings. So before computing embeddings, I would briefly want to walk through what these models mean, which I think I missed out to give a mention. But to summarize very quickly, the models VITT, B, L, and H are the models which are trained on natural images, where VIT B, L, and H comes from segment anything, and VITT comes from mobile SAM. And these four models are a good starting point if one does not have annotations, for example, or one wants to explore how segment anything works. And you can take, let's say, the advanced models or the generalist models for domain-specific tasks. What does that mean? The models which end with the name LM are for light microscopy, and they do a pretty okay job for cell and nuclei segmentation in light microscopy domain. And we have trained models for VITT, B, and L. And there are EM organelles model, which does a good job at segmenting organelles, which are roundish or potato in shape. And we have trained 3 models for that as well. Now, what do these names mean? So in a nutshell, T is the one with the lowest number of parameters, B being a bit larger, L larger than that, and H being the most parameter expensive. In our experience, Using VITB is always a good trade-off between performance and quality, for example. One could also experiment with other things, but then it gets a bit more expensive to run embeddings and doing downstream analysis with them. Okay, so we switch to VIT-BLM to see how cell segmentation would work here, and then compute the image embeddings. So let's go ahead and compute the image embeddings. We'll leave this open so we see the progress bar. Okay, I see random questions. I will start asking about them. Talking about fine-tuned SAM models on my own data, how should I decide to go for the default model? I hope that this answered my question, but I would mostly recommend to go with VITB because it trains faster if you are fine-tuning the image encoder, for example, because it's lesser number of parameters than the VIT huge, for example. So VIT base always is a good trade-off, and there's a slight bit of a performance difference, but I'm more inclined to say that it's rather on the negligible side. Okay, so the embeddings are computed. Let's try as the first thing is as automatic segmentation. You see different parameters over here because this is the automatic instance segmentation method supported by the latest microsam version. What this does is learns the distance maps, so the distance pointing from the center to the boundaries and the distance pointing from the boundaries to the centers, and then computing the seeds and markers from this to run seeded watershed as a post-processing. This is kind of the idea, and which is why we have some thresholding parameters on top. But if you are not aware of these parameters, I can, for most of the cases, highly recommend to run it by default. This is what I often do for pretty much any and every testing. So let's go ahead and run automatic segmentation without touching any of the parameters. And there we go. We see some segmentations, some issues here and there, and one small cell missed out of the corner. Now let's stick to this example and say we are comfortable with our segmentations. Let's go ahead and switch to the layer as auto segmentation, and then we commit the object. This basically means is that all the segmentations as automatic segmentation stored will be moved to committed objects. And now what we do is select different prompts to check out things. So we put a random box prompt over here and we try to segment the object. We see that the object was segmented roughly as we would desire. Let's go back to the current object layer and then commit this object. Now let's find issues. Aha, spotted this. So if you remember, this long looking cell is now split into different fractions, which is something I would not desire. So there are a few ways to do this. One way is, thanks to Napari, there are a few tools wherein you can merge these segmentations discretely segmented into one, or you can remove the entire segmentation and segment this using the interactive tool. For simplicity, I will show you some nice features from Napari itself. So we have this option called pick mode. And what with this we would be doing is select one of the foreground objects with which we would want to merge the rest of the objects. Select this over here. And then we would use the fill mode or the fill bucket to pretty much fill this without any issues. Now we see there is a small gap over here missing. So we can use the fill mode to still fill these particular holes easily. Now, once this part is done, we see that there is some issue with segmenting this object. So we take the pick mode, select the background, and then remove this object segmentation completely. This looks like an artifact, but for current use case or hypothesis, let's say that this is an object we want to segment. We put a point prompt over here, a positive point prompt, and segment this. This did not work as well, but we put another point prompt And this looks roughly as one would desire, for example. Then we go ahead and commit the current object, and there we go. We have our segmentations acquired as we would desire. And now I think would be a good time to open this session for a few questions related to this. I mean, if we have some more questions, we can go until the end and discuss a bit more. But I would be happy to answer a few questions on how we interact with the tools we have in front of us. Or a bigger question would be, could people install Microsam on their laptop? A thumbs up should work, or a chat would be fine as well, however you prefer. I see a few thumbs up while I scroll around. Okay. Okay, yeah, Brian says that Windows desktop does not work. Windows should work in principle, but we can also talk why is there an error or is there an error and try to brainstorm what's going on. Okay, I see a few thumbs up, so I'm hoping. Yeah. Okay, cool. Then, are there any questions? Luca, do you know how do we open the section for questions for everyone? Or how can they possibly be able to speak? I don't know.
I suggest if creating a breakout room, and if there's like some technical issues, I will go there and like let's see how we can resolve this.
Let's do it this way then. So what right now Luca will be doing is creating a breakout room. If you are interested only in 2D segmentation and would want to start things right away, you can move to the breakout room. And over here in the main meeting session, we will continue with 3D segmentation. So see how segment anything works for 3D images and try out a few more advanced tooling options. Cool. Luca, you can take over the breakout room. Awesome. Now we open the sample image for Luki, but one important feature before I forget. So this is, let's say we are happy with our segmentations. So we want to store these locally in our laptop. What we would do is go to the layer committed objects, select it, go to file, and then save selected layers from here. And then you can store it pretty much wherever you want on your laptop by providing a particular name to your image. And then once this is done, let's go to the 3D image actually. Or even better, let's start from scratch again, in case someone could not follow. So if I have a 3D image, I want to start annotating things or trying out the automatic or interactive segmentation. The first thing in the installed environment one has to do is type napari to activate the napari GUI. Now we go to file. Here are a bunch of sample images for 3D. There's Luki++ 3D data. We select on the image. If you do not have this downloaded, this could take a few seconds to download, but this is on the rather fast side. Then we select for annotated 3D from here. And now we have things pretty much set up for us the same as 2D annotator. So on the right, we have the annotator widget. On the left, we have our layers and controls on top. And now we need to try something a bit more advanced, but we have the instructions over there in the documentation. And this part is where we instruct you to install or get your image embeddings. Let me show you. Yep. So there's this function called download embeddings.py in which you can request for I would recommend to store it in your current working directory. And with -d, you can just type over there Lucci, Lucchi. And this should, in principle, this script coming from our repository, download these embeddings for you. You can also compute these embeddings, what we used to do before. But since this data is a volumetric data, this could take a while to run on our CPU resources. For my laptop, it often takes close to 20 minutes. So, and if you have a GPU resource, it would be easily less than a minute. Now what we do is the one we downloaded, not important question. What library did you use to perform the GUI? This GUI interface is called Napari, and you can create widgets answering the question from Ignacio in chat. You can use a Napari for building your own widgets and wrapping things pretty easily if you're familiar with Python. So this can be easily integrated without much effort. Okay, let's open the embeddings. Lucci-test.zar, here's where it will be downloaded for you. We choose this and just pre-compute the, load the pre-computed embeddings. This prompts us over here that the embeddings has been computed for the EM organelles model because this is a volume electron microscopy data, and we are interested, at least for now, we will see in a second, for segmenting mitochondria. So we press OK, and this should in principle log this pretty quickly. And once we have this logged and loaded, now what we do is check out the volume and then pick up an object of interest we would want to segment. So let's say this is one of those mitochondria I would like to segment, the small one. Let's go ahead and try to do this using interactive segmentation first. So I put a point prompt, and I can also use segment slice, or Napari also supports key bindings, which means hitting like using keys from your keyboard. And you can press S with this, and this should do the segmentation without the need of reaching out for the widget option, for example. Now, once I have this, this is segmented only for this current slice. Now, a big question could be, how can I segment this for the entire volume, for example? So let's try out to do one of these options, which is what we call segment all slices. And the idea of segment all slices is this will take the segmentations from the current slice and project extracted prompts in the forthcoming slices to get the segmentation of the entire object across the volume. Let's go ahead and press segment all slices. This takes a few seconds to do the segmentation. And you can see the progress bar over here running. Maybe I can also, oh, looks like it's done. Well, there we go. This segments the mitochondria as we would desire and does do the job pretty much as one would expect. Now, the commit function works exactly as we have seen in 2D. So we go ahead and look out for the current object, and then we commit the object to store this in the segmentation. Oopsie. I'll close this. Yes. I should move this here. And this should, in principle, segment the entire object and move this from the current object layer to the committed object layer. Now, once this is done, let's try out segmenting another object which is traversing a lot using box prompts. So let's choose this object over here. Now let's go to box prompts, mark a box prompt over here, segment things, and then segment this in all slices. So let's go ahead and open the activity console and segment all slices. This should be done. Okay. This looks like it did segment this. However, I see some issues. So let's go to the current object layer and try to see what's going on. Okay, did segment this, but let's say, for example, I would like to segment this object only until this slice. So what I do over here is choose a point prompt and place a negative point prompt in this particular slice, and then run segment all slices again. What this essentially means is that this interaction would define how far the object should be segmented and stopped. And there we go. Once we have the segmentation done over here, this stops potentially here, no matter if the object still exists in the future frames. And this is kind of a control measure one could introduce for themselves to do interactive segmentation. Awesome. Let's go ahead and commit this and try out another thing. So for this one, we will keep the activity console open. And let's try automatic segmentation on one slice only. So we run automatic segmentation for this slice. Yes. So this is doing, as we discussed in the beginning, a decent job for mitochondria segmentation at least. And for the interactive segmentations we stored, they are also there. Now let's switch off the interactive segmentations for now and only look at the automatic segmentation. So this automatic segmentation is there for one slice only. Now, can we do this for all the slices or potentially the entire volume? So there is this option called apply to volume, which one needs to select if they want to segment the entire volume for the particular organelle, or potentially actually for all the organelles in a bit more automatic fashion. We run automatic segmentation and we should see hopefully in a few seconds. Okay, this. We can let it run in the background because the process seems to be a bit slow, thanks to Zoom. But I would say we can take in a few questions until this runs to show us some experiments, because after this we go to discussions and then we take it from there for different tasks we want to solve and potentially try out a few more things. So I think the room should be now open for questions. I think, Luca, thank you so much. We have answered all the questions, if not most of the questions, if not all, and hopefully we can take up questions now. Luca, do you know how we let the members unmute? Because I saw a few flickers where people unmuted themselves, but I don't think they could speak, which was, I'm not sure.
Yeah, I think you can go to the participants button and then just ask to unmute them. If somebody has a question, then you can just unmute them.
Ah, so they have to raise their question and I right click on them and okay.
I assume that's
Then
the way.
okay, then please raise your hands and I will also Joanna has a question. Hi Joanna. Hi, can I somehow export the fine-tuned SAM model and integrate it to my pipeline elsewhere for batch processing? If I understand you correctly, which means that you fine-tune a model using MicroSAM, and then you use this particular model for batch processing in a different tool. So for example, SAMJ or some other potential tools, napari-SAM, for example, these tools, is that your question? Yeah. So over here, yes, you can do this exactly with the MicroSAM module or even without this. So we have this functionality which exports the MicroSAM models or MicroSAM fine-tuned models in SAM's semantic model checkpoint storing style. in which this model checkpoint can be pretty much used as a replacement literally anywhere, as long as it expects or accepts model checkpoints. So we have tried to keep this a bit more consistent with SAM so that our models, at least for interactive segmentation, should work out of the box pretty much anywhere. And for the automatic segmentation from MicroSAM, since it's an additional instance segmentation decoder stacked on top of the architecture, this is currently only supported by MicroSAM from what I'm aware of. So for this one, you can use our notebooks. Boop, boop, boop. Yes, we have notebooks over here. So one of the notebooks is fine-tuned SAM, and you can use this notebook without the worries of installation in the notebook platforms or GCP or other platforms wherever you have free GPU resources available. So I've tried this, and I personally like Google, like Kaggle notebooks a lot because it offers you free GPUs of quite high quality, I would say. And we have tried this on Kaggle. We have tried this on Google Colab over here, as you see on the screen. I hope my screen is visible. I'll increase the font size. And this should also work, this notebook, out of the box for your local setup. I hope that answers your question. Thanks. Thank you so much. Okay, we have two more questions. If I track one cell over all slides, when division occurs, it is capable of tracking the division and now track both cells? Unfortunately not. So we do not have a heuristic or let's say linking algorithm tagged along, but this is rather what we do for interactive segmentation, wherein if you have an object segmented over here and the, let's say, morphology aligns, then we use the heuristic for tracking very close to, semantically very close to 3D segmentation. And then once it's tracked for the mother cell, and once the cell splits to different daughters, you can take two different, let's say, track IDs, a new track ID to open a tracklet for child 1, another for child 2, and then you can continue tracking them interactively as well. And if I correctly remember, our documentation should have a tutorial video for our tracking tool as well. In case you do not find this, let us know. Okay, when doing prompt, is it recommended to add prompt on the middle slice of the object or the slice where the object is largest, or it doesn't matter? In principle, it does not matter. Wherever you want to put your point prompt, which is what I did, I randomly chose a particular slice, either at the end of the volume, beginning of the volume, mid of the volume. This should not affect because we do bidirectional label propagation. What this means is that we try to segment the object as far as possible in both the available directions. Okay, Orko has a question, but someone answered. Okay, cool. Luca answered. Thank you, Luca. Okay. When the images are very large, 10,000 pixels, can SAM accurately segment small objects or capture fine details of the object's contour at the scale of just a few pixels? I have tried this with a few gigapixel images in H&E stained slides. So from the histopathology domain for nucleus segmentation, and looks like it does an okay job, but there's a trick over there. So MicroSAM currently supports tiling window-based prediction, and you have to switch on the tiling window-based operation. What does essentially this mean is that when you are trying to script this, let me open my terminal. Automatic segmentation is still running. I can show you. Okay. So microsam.annotator3D, let's say, what does this show? So this is our CLI, which I'll talk about in a second, but just to briefly answer this. Yes. So you see over here, there are two important functionalities, which is the tile shape and the overlay or the halo around it. This is something what we support in favor of exactly this mention. When there are images of a higher resolution than what segment anything has been trained, that is on 1024 times 1024 spatial shapes, then we recommend usually to do this so that you have your segmentations even for fine-grained objects. Else, if you pass this image as it is, what segment anything would be doing internally is that it would reshape the entire image from so many pixels to fit to the size of 1024 times 1024, which loses the information pretty much for any and every fine-grained information or structures. And that would work for probably on a higher level tissue segmentation objectives, but not for very fine-grained or small contour objects. I hope that answers your question. Do you have any idea for improving auto segmentation of the macro objects? I work for adult plants, though on very consistent backgrounds, located mostly at the center of the image. The biggest problem of classic SAMs are usually edges of leaves or separate small leaves. Is there any case to improve automatic segmentation? I mean, a good tryout over here would be to use the interactive segmentation functionality from SAM, annotate a few of these images or your objects. So say, I'm assuming you want to segment leaves. I'm not really sure. But as an assumption or a point of discussion for now, let's say you want to segment the leaves individually. So what you would ideally do over here is segment using interactive segmentation the leaves individually. And you can fine tune it using the instance segmentation decoder support with Microscopy. In this case, this should in principle improve the performance for automatic segmentation compared to how segment anything performs. And I would say this would be a good starting point to try out things. Okay, Orko Jyoti has a question. Is the command for running SAM from command line with custom parameters when segmenting a lot of images in batch? Yes, we do have this. So we have a few CLIs exposed. I will walk you through very briefly through them. I would be happy to answer more detailed questions as well. So what we saw in the widget, pretty much everything and a few more parameters are exposed here. So the first CLI is annotated 2D. Next is annotated 3D, annotated tracking. One CLI is for running automatic segmentation out of the box for 2D and 3D images. We have one for image series annotator, which exactly answers the question what Orkojyoti you asked just now. Image series annotator loads a series of images for you, computes the image embeddings, and then allows you to segment them sequentially one after the other. And pre-compute embeddings does the part of computing these image embeddings and caching them locally on a particular directory you provide it to. Okay, did I miss out any questions? Yes, Luca answered about the how many image question. Thank you, Luca. When doing the middle slice, yes. Okay, I see a question. Still talking about fine-tuning SAM on my own data, mitochondria. I observed that SAM performs better with one or a few grid points as prompts when inferring from my tuned model. However, its performance seems to decrease as the number of points increase. Do you have any insights into what could be causing this? Also, could you recommend an optimal grid size for this scenario? With grid size, I am assuming that you mean the grid of points you provide and the grid of combination of points you place for automatic segmentation. I'm guessing that's the question, but I can't say for sure. Awesome. I don't really have a heuristic over here. It depends on the density of the objects around the frame. So if it's more dense or densely packed around, like clusters of cells, for example, a higher number of points in a grid is more favorable than lesser. But one could also argue that if the cell morphologies are elongated or larger, then you can have artifacts over the one cell which has multiple points, for example. But for this one, I think if you want this to work for yourself, I can highly recommend for mitochondria segmentation, our model doing a bit better job than SAM. Okay, how can one use SAM on a class 2 to segment stacks tens of terabytes larger? So Napari is currently not supporting port forwarding from clusters, which does not support internet. This means that unfortunately, this cannot be done on an interactive level. But if you want, you can batch process these processes using our Python library. And then you can segment these stacks in an automatic fashion pretty easily, I would say. Yeah. But this would be not interactive, so you wouldn't have access to the GUI. I hope that answers your question. Okay. Cool. Then I think we can check back with the automatic segmentation. It's almost there. Wow. Oh, wow. Okay. Well, and there we go. We saw that the automatic segmentation did a decent job for segmenting mitochondria throughout the volume, I would say. There are some issues I see. So if you see very closely, there is a weird one happening here. But what we can easily do is go to automatic segmentation layer. So select here actually, and then erase this missegmentation out. And then do we have more of these? Yes, we have more of these. Yeah. And this should rectify the segmentations for you. Okay. This should be everything for this part. Now, what we can do is pick a task of our choice. I'm not sure if someone has a choice of task here to recommend, but I will quickly give a shout out to something. So we have the scripts mentioned over here on how to make things work for you. If you want to reproduce exactly what we did now, or if you could not make the installation or some parts working, you can rerun all the experiments what we did over here from here and also look back at the recording for yourself. And the same goes for the 3D annotator too. Okay, so we have a few open tasks here. So one is for annotating cells using image series annotator for high throughput screening. We can have nuclei segmentation for light microscopy, or we can have organelle segmentation or cell segmentation for electron microscopy. Does anyone have a preference what they would want to see? I would be happy to hear some opinion. Uh, EM, I saw someone said this. Yes, thank you. Okay. So this step would assume, for example, if you want to do this for electron microscopy, this would assume that you would have to take the first step, which is download the data set we have curated for you. The next one, and this one would be different from the data we saw. The next one would be to download the pre-computed embeddings, because as we discussed for volumetric data, this could scale up very quick and could take a couple of minutes on your CPUs or your laptops. It's preferable to run this over GPUs, or if you have some spare time, you can just run this and do some other things. And the final step would be to running this part. Now for our case, let's go ahead and run this already. So we copy this, and since we have done the installation, we just try to run this. To quickly walk through this to everyone, what this basically does is replicates the functionality how we ran things in Napari, but using a CLI instead. So this is just to show that if you want to run a functionality either from, oh no, okay. If you want to run the functionalities either from Napari or using the CLI or pretty much Python scripts, you can do it from pretty much anywhere you would like to have. Okay, let's go back to Napari and we see this volumetric structure in front of us. Now let's say we would like to segment these very small organelles we see right here. Let's go ahead and put some prompts over here. We see if the prompt looks really huge and hurts to navigate, we can reduce the point size over here to reduce the shape of the prompt so that we can navigate easier with different things. Now we go ahead and try to segment this, and looks like it does a pretty good job. Now let's go ahead and commit this object. But before that, let's see another functionality. So let's say in theory, let's also put a random prompt here, another one here, and we see that it did a segmentation as one would not desire, for example. Now, what do we do about this? How do we remove all of these prompts and segmentations or missegmentations what one made? So there's this option called clear annotations, wherein if you press on this, this would remove all of these inputs which you provided at once for you to get started from scratch. So now let's put a prompt. Let's segment this. And with this, we can also clear the annotations again. Now let's try something. So let's try to segment this big membrane structure over here and see how things work. So let's start with box prompts because often it could be the case that box gives a bit more context for the object than just putting a point prompt. We put a box prompt over here, press S key binding, and we see that the membrane structure is segmented as one would desire. Now let's clear this annotation and try to get the outer structure of this membrane. So let's put a bigger box prompt and we see that, whoa, it did not work as one would want. Let's put a few more points here and there. So let's put a bit more interaction here and there. Let's remove this part, this, this, and this. This could be one of the workflows where one could get started to do some annotation if one does not have it at all from scratch. Now let's try some other structures in here. So let's say this is another structure I would like to segment over here. Let's try it out with point prompts. So we segment this, and there we go. Let's say for now, this is an object which I am happy about, and I intentionally wanted to segment this, for example. We go ahead and store this. This, in principle, is a good starting point for images where you do not have, let's just say, an idea of what I should segment or how many objects are there, and I want to get started with segmentation. Then one could just start with interactive annotation, get some dense labels, for example, these membrane structures, which are packed around pretty much everywhere. And then once you have these, you can use segment anything's fine-tuning structure to fine-tune on this entire data for yourself. Now, let's try to segment this in 3D, but this would take a while. Let's maybe try to see if we can segment a few more structures instead of this. So, let's say there is another structure over here, which we would like to segment. Let's go ahead, put some prompts. We see that there are some spillage or over segmentation happening. This can be easily rectified with some more interaction. Sometimes it does like distort out if one puts a lot of prompts, but we usually recommend people to interact with segmenting as less as possible, because the idea is it should do a near perfect segmentation in most of the cases if the model has observed these images. If not, multiple interactions usually distorts the image objectives or breaks down the segmentations around. Okay. Do we have any questions? I see a question. Were all three questions in the Q&A window answered? Is there a Q&A window? I don't know where the Q&A window is. Is it the meeting chat? I hope that's the meeting chat. But I'll read out the latest question. For a bit of fun and maybe efficiency, is it possible to activate Napari's 3D view, adjust opacity, and then observe the labels as they are generated throughout the volume during automatic processing? This would enable us to stop a segmentation in case it falls in layers other than, yes, we don't have a lot of segmentation here, but this can be done using this option over here, wherein if you press this, this changes the viewer's alignment, and then one could observe what they are seeing. Since the contrast or the foreground objects have such an overlapping contrast here, you do not see these segmentations as well. But if you want to switch out different layers, for example, you can easily do this. Since this is a 2D segmentation at the moment, you only see it for one particular slice, but this is how one could do using switching this toggle view option. All Q&A were answered by Luca. Thank you, Luca. Awesome. But can we see labels as they are being generated during the automatic process? I am afraid not at the moment, because we have switched the thread workers at the moment to one. To brief this idea out, this is a known issue, and we are discussing this with the Napari team right now, because currently something does not seem to work with these thread workers, wherein the idea is the GUI would run in one particular thread and the other threads would be engaged in the downstream tasks, segmentation or interacting with different consoles, for example. And this seems to be not working at the moment. But once this is fixed, I am more inclined to say that this should work, because if you toggle this over here, and you can also interact with the widgets on the right, then you can easily do these things, I would say, by seeing the segment propagate throughout the entire volume. But the prompt location, I am not sure if you can put prompts in the 3D viewer. I am not sure, honestly. I hope that answers your question partly. Awesome. Okay. I can, since we have time, that's really cool. I will close this and walk you through a few more things. So currently, what do we have on an overall idea in this process? So what we have is this fine-tuning notebook, what I showed a few minutes ago. And the idea for this fine-tuning notebook is to enable users to fine-tune segment anything on any and every type of data. And to walk you through, there are some imports. These installations, if you are running things on Kaggle, for example, you don't have to worry about the installations at all. Everything will be installed for you using these few scripts. And we download the data first. And over here, this is a sample data for high content screening, which we have provided. But you can also use your own custom data set to translate the idea similar to this. And from a lot of feedback from the community, we have updated our notebooks to make them a bit more easier to translate source images and corresponding labels to make the downstream fine-tuning a better or easier experience. And we do a few more tests over here. We check out that our images should in principle have dense annotations. And this is what I will come to in a second. What do I mean by dense annotations? We create the data loaders for the users and have detailed mentions for how to work with things. And then the data loaders are created, which are basically PyTorch data loaders, which are enabling fetching these images as batches and then training the model on the entire data set. Then we run the actual magic over here, which is the fine-tuning of segment anything. And this is the entire function which does the fine-tuning end-to-end. You do not have to write a lot of code or pretty much any code for running this part, actually. And if you see over here, for 500 iterations over the entire data, this takes roughly close to, I would say, 42 minutes on Kaggle GPUs. And if you have better GPUs with better processing power, you can scale this up pretty much for a larger data set or even for a smaller fraction of data. And we use functionalities to check for automatic segmentation. Looks like this did learn something from the default segment anything model. However, there are some artifacts which one could improve on. Now, what does dense annotations mean and why do I mention this? So there is this functionality called train instance segmentation in our fine-tuning notebook. What this basically does is adds an additional convolutional decoder for the user and learns the targets or the distance maps for the users to perform automatic instance segmentation on dense labels. This is currently not supported for sparse labels. So if you would like to use this feature, we recommend annotate as much as possible your foreground objects and then go ahead with switching this on. If you switch this to false, then in that case, it will fine-tune the segment anything model as it is, which is the image encoder, prompt encoder, and mask decoder in the segment anything fashion only, which means the supports you will have then will be for interactive segmentation. And after that, you will have supports for automatic segmentation using a grid of points. Mhm. Yes, this would be one of those. And we are always very happy to have issues, and we open issues from our side, which we think are still a work in progress. We invite the community to ask us questions if one has any. We are fairly active on ImageSC and we try to answer, and I try to make some promotion as well for Microsam. So we would be happy if you reach out to us with any and every questions. We would be glad to help you. And we have a few notebooks on top, which are under the directory of notebooks, which if one would desire to use not the CLI or the Napari GUI, but Python scripts only, there are 3 notebooks which one could use. The first one over here is the automatic instance segmentation notebook with the microsam models on immunofluorescence images. So the setup would be pretty familiar with what we looked at it right now. And we see that these are the ground truth labels for these images, and these are the cells one would like to segment, which are clustered together with each other. Now we have a lot of convenience functions and scripting where we walk you through what are these convenience functions and what do they essentially do. Then we run the segment anything model, which is trained on natural images out of the box for checking how the automatic segmentation works, which is with the grid of points, for example. And we see that it does detect some objects, but it's not something one would desire. So then we see out how our generalist model works over here. And we see that the generalist model for light microscopy still does not perform as one would desire because we want to segment these densely packed cell structures. And this does not do the segmentation as we would like. So what we do over here is try to see with another method. Sorry, my bad, just to rectify. This is the grid of point methods with the light microscopy generalist models. And this is the automatic instance segmentation supported by the additional decoder using microsam models. We see that neither of the two models perform as we would desire. So what can we do next are a few tips over here, wherein we can get some annotations, fine tune on this particular data, and potentially get a bit more better segmentations. And there's a big workflow over there, how one could approach these problems when nothing works out of the box. What can we do there still? So there are a lot of mentions over here. I can highly recommend to check this out. Evaluating segment anything model. So this is one of our experiments wherein we try to see, I think, interactive segmentation. Let me quickly check. This is the automatic segmentation method. Oopsie. So we also provide over here the procedure wherein you can evaluate your segmentations subjected to if you have ground truth labels. So this is how we also benchmark all the results with our models for instance segmentation using calculation of average precision. And this is basically how we call as segmentation accuracy. And we calculate segmentation accuracy over IOU 50%, or we can calculate the mean over a spread of IOUs, for example. And this is pretty much what the model does. There is one additional experiment what we showed is using point prompts in a bit more automatic fashion. What does this mean? So what we provide the users is a possibility to extract, I think Anwai answered this already. Am I correct? Yes. Yeah, the question from Daniel I answered. Yeah, thank you. So what we do over here is extract in a bit more automatic fashion to replicate the knowledge of how a biologist or an expert would annotate images by deriving point prompts from here and doing iterative prompting. And we see that what does iterative prompting mean is that we start with the first instance as putting a point prompt on the objects and then iteratively improving them with a positive point and a negative point. And we see that the model does not do a great job in the first try, but if you iteratively improve it, it does improve the objective understanding of what it's looking at. And do I have it for the box prompts? Yes. So, oh, this is probably our model. Yeah. This is our model. Do I have it for box prompts as well? Yes. So you can do the same for box prompts, wherein the idea would be you start with a box prompt, wherein it already does a pretty okay job, I would say. And then you can iteratively improve if there's a scope for, let's say, mistakes and get better segmentations for yourself. And There is a bit of a workflow of if things work here or if not. And I would be happy if you give it a read and let us know if you have any issues. Finally, once we have checked how automatic segmentation and interactive segmentation work, how can we proceed with, let's say, if things don't work and I could manage to get some segmentations using interactive segmentation, for example. So this would be one of those examples on HeLa cells. This data comes from the cell tracking challenge. And this is the image with the paired ground truth. This would be the creation of data loaders, which we have now simplified in our legacy notebook. And once the fine tuning is done, since the data fraction is small and the ROIs or the patch shape is smaller, this takes a bit lesser time to, compared to the previous example we saw. And then we run automatic segmentation to see that for the test time images, our segmentations roughly look as one would desire. So the cells are segmented as we would like. We see a segmentation or a cell in the corner. If one would identify this as a cell which is valid and one would want to segment, we could start with this fine-tuned model. You can also download these fine-tuned models by clicking over here. I mean, this click would in principle not work, but once you fine-tuned it, running this particular cell and clicking over here should give you the model. And then you can put a bounding box or a point prompt to segment these particular objectives. And yes, that is pretty much everything. This is our repo wherein we are very active, I would say. And the work is, the Microsam tool is a work in progress. We are always happy to welcome discussions. And if you want to know anything more about things, just open an issue or discuss things with us via Imagesty. We would be happy to answer. And if there are any questions, Luca, can we still open the room? We have like 5 minutes, I think, tops. But can we open the room where people can talk?
Yeah, I will open the room. Wait a second.
Yeah.
No
Okay, meanwhile you do that, I'll answer a question. When using the vanilla VIT-BLH models, the Microsam fine-tuning framework, are these models completely untuned or are they partially fine-tuned? In other words, if I intend to fine-tune the original SAM model but don't plan to work with microscopy images, is Microsam still? Yes, yes, we do. So we do not fine-tune the vanilla models as it is. So when you see VIT-B, VIT-H, VIT-L, and VIT-T models, those are the images completely trained on the natural images. We have not fine-tuned or updated the weight parameters at all. And you can use them for downstream tasks. For example, I often see tasks around in Imagesty, and I try to help the community with, for example, segmentation of ultrastructures in rocks, for example, or some other structures in plants, what we just discussed. And you can do this pretty much if you have some annotations from your side, or you can generate this using SAM as well. This model from our side has not been fine-tuned at all. And from what I am aware of, has not been fine-tuned on medical images in general at all. I hope that, biomedical images, I'm sorry. I hope that answers your question. Nice, thank you so much, Ivan.
Hello, can you hear me?
Yes, I can hear you. I don't see you, but I hear you.
No, yeah, I cannot put on the video, but that's anyway. Well,
no
as we
worries, no
talk.
worries. Octavio, hi, I'm sorry.
Hi, no, don't
was
worry,
like,
don't worry.
How do I know this person's voice? I'm sorry. Go ahead.
It's fine. No, I mean, I think I echo what the people are saying, that this is pretty fantastic. I am now playing with the 3D set. And I think something that we discuss on the I2K is that how can the community, for example, I will have some data available or those kind of things. How can we contribute that to the general SAM project if there is a more straightforward way than just like sending you the Zenodo link, for example?
Thank you so much that you asked. So if you see the screen open. This is a library called TorchEM, in which the idea or the vision of TorchEM in general is to assimilate deep learning packages, methods, models, and data sets in one place so that they can be reproducibly run and unified in one place. And thanks to Constantin and now us PhD students, we are pushing this forward to make this a bit more stronger as a package. And if you go to TorchEM datasets, you will find a pile of datasets over here, which we are constantly improving pretty much on a daily basis. And you can go to repositories and see these open source datasets, mentions of their licenses, and publication information pretty much for different domains. So this is for electron microscopy. This is for histopathology over here. This is for light microscopy in front of you. And we have another repository for biomedical image segmentation as well. So we are very happy if you create an issue over here and discuss about your data structure, or even if you want a starting point on, I have images, I have dense annotations, what do I do? Help me. We would be very happy to walk you through. In addition, TorchEM is one of the core frameworks behind Microsam. So Microsam runs built on some of these data loaders, and PyTorch supports thanks to TorchEM as well.
Very
I hope
cool.
that answers
Thank
your
you.
question, Octavio.
Yeah, no, absolutely. You will see an email from me eventually once I have the data.
Lovely. Looking forward. Okay, the forum is open to questions, by the way, and I think anyone and everyone can unmute themselves if you want, and we will be here for questions. Is Brian still here? Yeah, I see him. We need to figure out. Luca, did we figure out the issue for Brian on Windows, or?
Not now, apparently. I didn't have time to like.
Okay,
no
worries, no worries. I will talk to Brian and then we see what's coming up, because it could be one of those minor things, but we can have a discussion with Brian. Awesome. Okay. Any more questions? I can post an image and show you my. Lovely. Thank you so much, Brian. Yeah, I would be happy to follow up. Any more questions? Or if we missed out any question and did not answer this yet, now is the time.
I assume there will be some unanswered questions in the chat. I couldn't answer them all. I tried my best.
I think you answered pretty much everything. We can quickly, I think people are still around. Yes, I see a lot of people. I'm just waiting if someone has a question. That would be more easier than going through the chat, actually. Because, yeah. And I think Krista also affirmed that you answered pretty much all the questions. So, yes.
Okay, we did.
Awesome. Yeah, thanks. This was fantastic. I think time is up now. Vanessa set up the recording stuff. Okay, thank you so much, Krista. I think the time is done, and there are there's an awesome line of workshops. I highly encourage everyone to join pretty much all of them if you have time. And with that, it's me and Luca signing off. Thank you so much, everyone, for being patient and listening to a lot of discussions for a very long time. Thank you so much.
Thanks from me too. Hopefully see you.
Hopefully see you around, everyone, on Imagesty GitHub, or hopefully next year's in 2 years at I2K. Cool. Then I'll end the session. See you, everyone. Ciao.
Yeah.